How do you keep your soul sharp? How do you retrain your skills and take on new challenges? Today on the InfoQ podcast, we're talking to Lynn Langit. Lynn is a consulting cloud architect who holds recognitions or awards from the three major cloud vendors, Azure, GCP, and AWS. On today's podcast, we talk a bit about what she calls her 25% time, or how she learns new skills while combining work for social good. Specifically today, we discuss projects Lynn's become involved with around genome research. We discuss some of the ways she was able to contribute to the scientific research. We talk about the hipster gene. We talk about strategies for moving to the cloud and some of the realized benefits with cloud adoptions that she saw in the scientific community. Finally, we wrap up a bit with programming languages and a little bit about their evolution. Hello, my name is Wes Rice, and I chair the QCon software conferences in San Francisco, London, and New York. In addition to the regular QCon conferences, I chair a 2-day vertical software conference around machine learning as seen through the lens of a software engineer. Rather than another machine learning conference for machine learning specialists, this is a conference for the SWE, for the software engineer, and focused on how machine learning is reshaping the way we think about problems in software. The schedule is forming now. Check us out at QCon AI to learn more. As always, thank you so much for taking us along your jogs, runs, and commutes. And thank you for joining us on the InfoQ podcast. Lynn, thanks for joining us today.
Thanks for inviting me.
So you corrected me on something a little bit before. I thought we'd talk a bit about it. Your role with teaching kids programming has changed a bit. You want to talk about that before we jump in?
For sure. Yeah. After 11 years leading an organization of volunteers, creating courseware designed for middle school teachers to introduce children to programming with TKP Java, the work now is being led by my colleague, Jessica Ellis. She has started her own nonprofit called TKP Labs, and they use TKP Java as part of their curriculum. She and her group have also developed other courseware around data science and IoT. And they've basically built upon the foundation, and they are now continuing the work, and I'm acting in an advisory capacity.
That's very awesome. What are some of the examples of things that she does with the kids?
In working with the kids, she works with TKP Java to get them started with a full OOP programming language. And then she has done some unplugged activities because she is also the director of the Boys and Girls Club in North San Diego, and there's an industrial kitchen. And so, for example, they did this activity called the hummus experiments, where the kids made different ingredients in hummus and then designed a set of data science experiments, not just which one's best, but what are the ingredients and how to ask the question. So experimental design, and then collected the data. And then they were inspired by the work of a great guy in data visualization, David McCandless. Information is Beautiful. He's actually in London. And they used materials, and on the walls of the club, they visualized the data results of what was the best hummus. So they're doing all kinds of really interesting computational concepts, from programming to IoT to data science. And she's created this program that she runs in the summer and then now works with different organizations globally to prepare teachers to bring this into the classroom.
That's awesome. I love it. A past student of mine who is teaching high school, and we had a discussion just recently about some of the investment Microsoft is making into high schools, actually start a CS education as early as high school. And he's been super excited about that. So that's awesome. That's great. Well, thank her for all of us, because it sounds awesome.
Oh, I will.
So you have a practice called 25% time. Can you tell us a bit about what that means and maybe how it's helped shape your career?
I tend to incorporate what I call 25% time into my professional life. I have my own business. And so I allow that time to pursue my professional development and then try to also combine that with working on socially good projects. So a few years ago, a friend of mine had cancer, and she's okay now, but she was unable to get personalized treatment. And at that same time, my daughter had the opportunity to go to Stanford in the summer of her junior year and take cancer biology. And she was learning about personalized therapies that were becoming available because of the cost of sequencing the genome and the research being done around genomic editing, CRISPR-Cas9, that was allowing for more new types of therapies that were less invasive to be made available. So I became really, really interested in helping to work on this problem when my daughter came back from school and said, Mom, these people really aren't using the cloud, because I had been working to build cloud data pipelines in other verticals like ad tech and finance. And, I was really familiar with some of the patterns for taking huge amounts of data and doing complex compute and getting a quick result. And so I was pretty surprised by what I was learning about the bioinformatics community. But as I've been working with them, it makes sense because the price of genomic sequencing coming down has been a relatively recent development. And so they haven't had these huge repositories of data to work with for many, many years. It's kind of a new thing. So how would they know how to build big pipelines? So I got really interested in working with them. And I happened to land with this group in Australia. And so that's been my first big project that I've been working on for the past couple of years.
That's pretty awesome. When you talk about large amounts of data, what are we talking about?
Well, the physical size is one dimension. But what's actually really interesting is when you look at the genome, it's 3 billion letters, 3 with a B, data points, and variants of even, 1 or 10 or 15 genomic variants, 15 letters being different, can be statistically significant. So you have this matrix computation that you have to do to find the genomes of interest. Because, of course, you start in the lab. So it's wetware, it's biology. So they make mistakes, right? And so you have to analyze the snippets of the genome over and over and over. And then you have to look for the statistically significant differences. And these are matrix processes because of the width of the genome. So you have to get the variance out. Then you have to combine with sample sets. So, we started with 1,000 genomes, but where the work is going now is to get reference data sets around specific disease conditions. So like pancreatic cancer, for example, or breast cancer, and then to further segment those genomic variants so that when people present with disease conditions, they can reference against the more stratified data sets and move towards personalized medicine. So in order to build these data sets, you need really fast matrix computation. And that's, again, the area that I'm working with.
Are you helping them with building data pipelines, or is this a machine learning problem?
Both. A pipeline with machine learning. In the case of CSIRO, they had built a library to help to identify variants of interest. Now, the disease condition they're working with actually is not cancer, it's ALS, the ice bucket challenge disease. So they're trying to work with a group of researchers globally and build that reference data set. And so in order to do that, they're using various machine learning methods to find the statistically important variants. So they were using HALE, which is a logistic regression library that was put out from the Broad Institute in the United States. But that does single variant. And they wanted to work with an algorithm that would find multiple variants because that more closely related to disease conditions and clusters of variants. So they experimented. They started with k-means to just find clumps in the data. But then as they got more reference data sets, they wanted to use a supervised algorithm. So they couldn't find anything that would scale properly because of the matrix sizes. They started with Spark and they wanted to use Spark ML. But basically, they couldn't get big enough compute clusters because of the explosion of the matrix. So they took a sort of a kind of good old algorithm. They took random forests and they put splits in it, both vertically and horizontally. And they made that as an open source library. It's called Variant Spark. And when I met them, they were running it on their shared Hadoop Spark cluster internally. They have one cluster, and so they had to wait. And plus, it took a really long time for one run. It took like up to 500 hours. I was stunned. I was like, you got to be kidding me. 500 hours to ask one question? I'm coming out of ad tech where it's like seconds, right? And they said, well, what can you do to run this on the cloud so we can get a faster run? And that's what I've been working on, to figure out how to implement this. So it's not really the pipeline yet. It's actually just that particular batch because it's so complex.
Let's talk about that process then. You met them, they were running on a single Spark cluster, and you helped them move to the cloud, how to get to the cloud. So what did that process look like? How did you kind of start that journey with them?
Yeah. So the first thing that I did is I believe in like lean startup principles. So a minimum viable report or minimum viable data process or whatever. And so you want to get this out to more people, right? And so see if they could use it before you go around optimizing it. So the first thing that we did is we use what's really common. We were talking about this before we started the recording. We took their open source repository and we built a reference Jupyter notebook as a sample. And kudos to them. I said, okay, can you make it sort of like fun or cool so it's kind of catchy? And so they came up with this idea, because you can't use like real patient data because it's, privacy, of making what they call a synthetic phenotype And that's biology speak for a fake disease. And their fake disease was hipsterdom. And because they're biologists, they took 4 traits. It was the proclivity to drink coffee, some characteristic of your retina that would make you prefer checked shirts, facial hair, and then monobrow. And they're actually genetically related. So if you do a 23andMe, you can actually check your own hipsterdom, which is hilarious, right? And we made an infographic and all this. But anyway, so we had this notebook. So that was cool. All right. So then the question is like, even as a sample, how do you run this notebook? Because like the problem was they had to wait for time on their shared cluster. So I started with something probably pretty unexpected. I started with a SaaS solution. We went with Databricks on AWS, which is managed Spark, because they have a free community edition. And we had a little small data set just to show how the algorithm worked. And we actually used that as a basis for discussions and talks globally and had some really good success with it. We got more people involved in the community. We got people committing to the open source. We got people volunteering on the project. We got people excited about it. So the first step wasn't even scaling. It was like getting the interest.
So you got people in Jupyter Notebooks connecting to a hosted Spark solution, and you started identifying a hipster gene. Tell us about that. What did that look like?
We made a synthetic data set. We referenced it against 1,000 genomes, and it was kind of like for machine learning, like a reverse TDD. It was, we labeled certain data as hipster, not hipster, based on the formula. Like if they had this gene as a variant, this gene as a variant, and then we ran the algorithm, and it's random for us. And then what we should find is we should find that the labels where we labeled one as they're hipster or 0, they're not hipster, that should prove true for genomes of those variants. And it did. So the algorithm worked. So it was like a proof point of the algorithm. One of the situations is again, this is really surprising to me because in like finance, you have all, TensorFlow and deep neural networks, and you have all these really sophisticated machine learning. And what I found a lot in bioinformatics was more like the scikit-learn kind of machine learning, because the scientists were more focused on the science and the technology was in service of the science. And so they weren't out like studying TensorFlow on the weekends. They were saying, okay, I learned scikit-learn in college, so can I just use logistic regression? Like using random forests was kind of a novel approach in the field, which I was surprised because that's not a new algorithm.
Okay, so once you got this MVP done, you've got people involved, you've got people actually seeing results and actually seeing visualizations inside of Jupyter Notebooks, I imagine. You said you made a hipster infographic. What happened next? How did you start kind of getting them into actually a cloud environment with the pipeline?
Yeah. So what we then did is working with the team at CSIRO in Australia, we tried to evaluate different cloud vendors. Now, being in Australia, they had less options at the time we started the project because the data has to be kept in country because it's health data. And so at that time, there was no GCP data center. So even though Google has a strong offering, we had to kind of eliminate them because they weren't physically in Australia. Now, they've subsequently opened a data center. So it was really between, Azure and AWS in terms of public cloud providers. And so we basically just kind of did an evaluation, and based on the cost of the services, because we wanted to start either with, just IaaS, so EC2 instances with Hadoop Spark on them, or with PaaS, which would be EMR. And because they didn't have any dedicated DevOps people, it was like kind of a side task of the researchers, we decided we'd start with PaaS, because that way at least they wouldn't have to install the binaries and that kind of stuff. We got that up and going. And then it was really an education process because in this domain, they hadn't used managed cluster. Now they had a separate project, which was downstream for this data. It's almost like a find where to cut for a CRISPR. The output is like a green line or a black line, and it maps their genome. And if it's green, cut here because there's characteristics of the DNA. And again, I'm not a biologist, but like how tightly coiled it is or some other things like where it's more appropriate to cut. And they had a grad student who had gone to an AWS summit and they had presented the serverless pattern there. And he built a search tool using the pure sort of serverless pattern with, buckets and DynamoDB and Lambda. And so they had a success kind of relatively quick like on Amazon. So they were kind of inclined for Variant Spark to say, what can we do in Amazon, because they had that success.
What were they actually doing with serverless?
So with the serverless thing, it's called GTScan 2. And basically you take the results kind of coming out of Variant Spark, and then you feed them in and it visualizes them. It's kind of like the next step down the pipeline. These results are significant. Now let's add additional data around this so we can kind of see where we're going to cut with CRISPR, And that was a separate tool that they built, and they built it pretty quick like. And they were like, oh, we like this. So the first question they asked me was, can variant Spark be serverless? And of course, I had to say no, because it has long-running compute, unfortunately. So that we couldn't do serverless the way the algorithm was written, and they didn't want to rewrite their algorithm because it was working. So we right away, got rid of that tier. We then eliminated the IaaS because they didn't have a DevOps person. So we went to the PaaS. And so we were then in the PaaS, and then it was a process of helping them to understand the true economies of cloud. So things like AWS batch and spot instances so that they could burst. And they were able to get that. And then some DevOps stuff like templates, like CloudFormation, so they could, click to set it up and click to turn it off. So, it's a lot of stuff. If you think about, go back to when you started on cloud, it's a lot to learn.
Yeah, absolutely. So you took something on-prem, you took a Spark cluster on-prem, moved it to a platform as a service in a cloud, and then you use the bursting capability essentially of serverless to be able to kind of scale horizontally to be able to handle the things that they needed on demand.
Yeah, we use bursting, but not serverless. We couldn't use serverless because it's long-running compute. So bursting with an EC2. So it's batch and or spot instances. And then it was really interesting because along that time, I was doing some other work. And it was actually with my daughter. She was doing some research in the summer. And she was a typical university student having to connect to a mainframe to run a bioinformatics process. In typical college, she had the old Python script and was supposed to update it. And, every time she made a change, she had to supposedly connect SSH to the computer. I was like, no, let's make a Docker container. That way we can just run the tool locally. And it was like, wow, that seems cool. So we took the tool, it's called BlastN. It's a real common bioinformatics analysis tool of these variants. And then we also put a Jupyter notebook on it because I just prefer Jupyter notebooks because of the visualization to like a command prompt for bioinformatics. And we built this little prototype. And then interestingly, Databricks, where all the committers for Spark work, came out with Spark 2.3, and they said, hey, now Kubernetes can be the controller rather than Yarn for Spark. And I said, hey, maybe we could move to containers. So I talked to Amazon, and thanks to Amazon, they actually helped fund this work. And so we did that. So we took what we started with EMR, and we said, what if we could make this into like a data lake? What if we didn't have to use HDFS? What if we could just use S3? And what if we could use containers? Because that should scale more effectively. And I'm happy to say we shipped it. So in September, we were able to do it. So pretty happy. The big run, the 500 hours, we got down to, ready? 10 minutes.
That's a great story. So what's next?
What I'm hoping is next, I'm in discussions right now. You might remember those folks who CSIRO was using their algorithm, HAIL, from the Broad Institute in Boston. They sit right across from MIT. They're the Broad Institute at MIT and Harvard. They have created a pipelining solution called FireCloud built on GCP and using their set of tools starting with GATK. And I had explored that as a kind of a reference to potentially build a pipeline with Variant Spark. And I was at a conference, Google Cloud Next, and I got introduced to one of the designers of the FireCloud. And so I just was my enthusiastic self and said, it would be my dream to collaborate. So I had some meetings with the Broad out this fall, and we're in discussions now with the potential of me making some sort of contribution, which is really incredible because they really sit at the fulcrum of some of the most important research in the world and the actual production. So they kind of sit in the middle of academia and production in the United States. When I went out to Boston in September, there are probably 15 genomic research companies physically right around the Broad. And it was just such a fascinating visit. They were so kind to me. I spoke to 14 different people there, all the way up to some people that were involved in the original discovery of sequencing. And I just felt very privileged even to get their time, much less if I get the opportunity to work with them. So that's the dream. We'll see.
Yeah, that's very cool. So one of the things I remember talking to you about is that you have this love of lifelong learning. And I specifically remember you keynoted at QCon London a year ago, 2017, with Martin Thompson. It was Engineering U, I believe. In that, I remember a big round of applause because you said you taught yourself calculus at the age of 51, I think you said. So everything you're talking about is kind of like your career kind of started later in life, right?
Well, this career, I mean, I've had a lot of careers. I've done this 25% time thing all of my tech career. Long, long ago in the summer, I used to go to Lusaka, Zambia and work on an electronic medical records project. Did that for 5 years every August. Again, I've seen what can be done by a really small group of curious technical people in collaboration with people that could make use of those resources. And so it's a cool way to be.
Let's talk about that. You mentioned that before, 25% time. What does that mean?
That means literally on my calendar, because I'm kind of, German like that, I color code things. So there's green for money, there's light green for potential money, because you got to make money if you're a consultant. That's just the way it is. Somebody's got to pay the bills. And then there's orange for my 25% time. And, for a while that was Zambia. For a while that was teaching kids programming. And now that's bioinformatics. And that could be working with the client. It could be learning. It could be studying. It could be collaborating. It's non-billed time that is in service of someone else, basically.
One of the things that you mentioned before, you actually have a practice of teaching yourself one new language every year. Is that right?
Yeah, again, I'm so non-traditional in so many ways, right? I mean, one of the other ways is in university. I do have a degree, but my degree is in linguistics and I studied foreign languages. And I stopped taking math when I was like in the first year of high school and no computer science, nothing in school. So I have this idea that computer languages are interesting from a linguistics standpoint, which is kind of interesting because it's not usually what people study them for. For example, this last year I got really interested in ballerina language because I'm also interested in visual dialects. And ballerina includes live visual diagrams, which I think is really interesting. And ballerina includes annotations, so you can generate YAML files for Docker and Kubernetes, which of course I was working on that with the bioinformatics, and YAML files are terrible. And so anything that can generate them has got my interest. And ballerina was written as an integration language between APIs. And I find myself using a lot of APIs for machine learning, for authentication. So I think it just interests me. The year before, I learned Kotlin, because Kotlin was an evolution of Java. And I had done all the work with Java with kids. And I kind of was tired of Java and I wanted to see something better. So Kotlin was really interesting to me.
I can see a whole talk around, how in linguistic and languages, there's like shifts. You've got P for F and things like that. So it'd be interesting to actually see changes in languages that have been influenced by other languages that were like the software equivalent of a consonant shift, for example.
I actually have long wanted to do research, and I wonder if in the next phase of my career, I'm not more involved in academia, because I have wondered about this and I have wanted to find resources and I haven't found them, which makes me want to write and research in this area.
We're actually doing a talk at QCon London this year that I'm going to have to pick your brain about now. Initially, what we called it was domain-specific languages, which we couldn't use because DSL takes us a specific area. So we reversed it for languages for specific domains, and that's not quite right. So we're still working on the title. But basically, when you're working in data science, you see R and Python. You see lots of infrastructure using Go. You see a lot of high-performance people or networking operations using Rust, for example. You're seeing different languages kind of arise, and you mentioned Ballerina now for generating YAML files, but you're seeing like languages arise that are really good at given domains and things. So we'll have to pick your brain and see what kind of ideas you have there for that.
Yeah, well, one of the things I think, as I've been doing so much work in data science with Jupyter Notebooks, is this idea around integration of visualizations. Because with the increasing amount of services and data and complexity of algorithms, everything from like TensorBoard, I recently found a tool that I was really excited about. It visualizes a training of a GAN, which I'm really trying to get my head around GANs, and I got some work to do. So that tool was helpful to me. So as we increase in complexity in our systems and our data processing, that's why Ballerina was so interesting to me. Incorporating visual with written seems to me to be a really open area for us to do work in around our tooling and around our environments.
Well, that's one of the strengths of Jupyter Notebooks, right? I'm trying to remember Donald Knuth. I mentioned this in a podcast actually the other day that I did with Charles. But Donald Knuth talked about literate programming, a programming paradigm where source code and documentation were kind of interspersed together. So it was all together into one compilable set of code. And Jupyter Notebooks is very much a step in that direction. But that style of programming is just very expressive. You document with Markdown, and then you write code that could be in many different languages, pulling from many different data sources. It's just very expressive way of being able to get to like an answer, ask questions and get to an answer. I really like Jupyter too. So if you could leave our listeners with one final thought, what would that final thought be?
So one technique that I use when I'm learning new languages or programming paradigms is I try to bring someone along with me because I am senior in my career. So I find myself these days working with college students, and I do a lot of remote pair programming. And it's been such a great, fun thing to do. I highly recommend it in terms of learning. I've been working with a lot of college students who are very fresh in terms of data science, an area that I'm working on augmenting my skills. And most college students don't know anything about the cloud. And so it's kind of this fair swap. We usually use a tool like VS Code, and then we will program for an hour or two at a time, build some small prototype thing. And I've been doing that. I have about 4 or 5 college students, and I really like doing that. And it's also a good way to give back to the next generation.
Very cool. Well, Lynn, thank you for joining us on the InfoQ podcast.
Thank you for having me.